We will be demonstrating the effects of inertia with simple objects consisting of a skateboard, a tennis ball, and the side of a wall. Whilst doing so, we will also observe and describe a plethora of simultaneously occurring physical phenomena such as elastic collisions, velocity, and Newton's third law of motion. To set up our demonstration, we have merely acquired a simple skateboard, which will be our stipulating force of motion, and a common tennis ball, which will be our reactant that will provide our observations of Newton's first law of motion, inertia. We will be rolling the skateboard along this predetermined distance, at the end of which lies a wall. When we first begin to roll the skateboard, we may observe that the tennis ball will attempt to remain in place by rolling backwards along the skateboard. This demonstrates the definition of inertia that states an object at rest will remain at rest until acted upon by an outside force. In this case, the friction between the skateboard deck and the tennis ball forces the ball to continue forward with the board. As the board comes in contact with the wall, the ball continues forward, thus depicting the remaining definition of inertia that claims an object in motion will remain in motion until acted on by another force. In this case, the opposing force that will slow the ball will be the air resistance and the friction between the ball and the skateboard. If given conditions of a vacuum, the ball would have continued moving endlessly in the direction of motion that the skateboard provided it, despite the skateboard having stopped. Also, you may observe that when the skateboard collides with the wall, it is repelled backwards. This is a result of Newton's third law of motion, which states that every action has an equal and opposite reaction. In this case, when the moving skateboard strikes the opposing force, it is pushed with the same force that was generated from its momentum, which proves to overpower the friction between the wheels and the ground, thus resulting in the skateboard being pushed back. If the friction between the wheels and the ground were equal or greater than that of the force generated from the collision with the wall, then the skateboard would remain in place. The type of collision taking place in this instance is an elastic collision because the two objects remain separate rather than becoming tangled, as would happen in an inelastic collision. This concept is important to understand in our industry due to our requirements to emulate reality in the most convincing illusion we can muster with digital technology. Specifically, if we were to animate some form of CG collision between cars or any two objects, we would need to be able to accurately depict what would happen to objects inside the cars so as best to sell the illusion of reality.